This is the practice angles handout that is independent work. In case you feel like you need to watch some more examples being done, I will do a whole bunch of these guys with you, and then you can complete it on your own. Answers are given on Haiku. Okay. If we're going to draw an angle, remember that all angles are going to have the initial side here across the x-axis. And now if we want 300 degrees, well, that's going to be a little bit shy of our all the way around 360, and that is a 300 degree angle. I'm going to do number 2 because it's a negative angle. So when we go in the negative direction, I get that we're not so tuned into the negative numbers and where the angle would end, but just know that halfway around the circle is 180, so this negative 135 is going to be over here somewhere. Okay. So moving on, I'm going to come down to number 5, so we're going to do some with radians. Okay, so now when I have this, hopefully you recognize that for 6 over 6 pi, that is your 1 pi, and we do know that pi is 180 degrees. It's halfway around the circle. So as soon as I see the denominator is 6, I'm kind of going to count by 6. That's how I do this in my head. So I'm going to go 6, 12, and one more would bring me to 13, one more sixth. So I'm going to do 6, 12, 13, and I'm going to end somewhere over here. Okay, let's flip over. Next up, number 7. Okay, now we're going to go negative. So that's again 6, so I know 6 over 6 would bring me to here, but 5 over 6 is going to bring me a little bit short of that, and I'm going to go to about here. Number 9, it's fourths, so I'm going to count by 4s. I'm going to go 4, 8, 9. And there it is. That's what that guy is going to look like. This one here, again, fourths, so I'm going to go 4, 5 is going to be up this way. And then when this one comes around, let's see, it's going to be 6, 12, 18. But that's 17, so I am going to stop a little bit short. I keep ignoring my initial side, but hopefully you recognize that the initial side is here. And we're going in a positive direction, so 6, 12, 17, 6. Okay. Whoop, that one's done. All right, so then here, just the back. Oh, that was the back, number 15. We want to find the measure of each of these angles. Okay, so we are going an entire circle, so that's going to be 306 degrees, plus this extra little bit here, which they're telling me is 80, for a whole 440 degrees. Let's take a look. Maybe I'll do this one right here. So pi over, right? So we're going to be counting by 4s, so that's going to be 4, 8, and one more. So that's actually going to be 9 pi over 4. If you like the way we did it before by adding an entire circle, so that's my plus 360, we can do that here also. We went a whole circle, so it's going to be plus 2 pi. So now you can do 1/4 plus 2 in your calculator, or you can know that it's going to be pi over 4, put a little 1 there even though it hurts me a little bit, plus, and then 2 you know is going to be 8 pi over 4, and then there's where you can get your 9. This guy right here, it looks like I'm going to go 1 complete circle, 2 complete circles, so right now it's 360 plus 360, or we can think of that as 2 pi and 2 pi. And then I'm going to go another 90 and 90 and 90, so that's another 270, or 1/2 pi, 2/2 pi, 3/2 pi. I pull up my calculator because these numbers are getting big. 360 times 2 plus, what did I say, 270. It's easier for me to type it in that way. 990. So this is a 990 degree angle, awkward angle there, sorry, 2, 2, and 3 halves. So 2 plus 2 plus 3 halves. May as well do this right now. You can see that it's 11 halves. 11 pi over 2. I always say 11 pi over 2, even though I'm kind of thinking of it as 11 halves. Okay, let's move on. State the quadrant in which the terminal side lies. Well, let's actually draw the picture. Minus is down here. Well, that's quadrant 4. Here's a picture. Oh, 3's, right? So that means it's going to be 3, 6, 9. Ooh, not quite 12. It's going to be down here. Again, quadrant 4. And then right here, 6, because again, I'm going backwards. It's negative. So 7 is going to be right here in quadrant. Okay, so now this guy right here, convert each, like a mess of stuff underneath, convert each into radians. Okay, so here I have my degrees. So now since I have degrees, I want to cancel degrees. So 180 degrees will cancel. Put the pi on top. I'm going to cancel my zeros. 57 and 8, both 3 goes into both. So I know the denominator is going to be 6. 3 goes into that, 1, 9. You could do the rest of them the same exact way. Now when we go backwards, if we want to go 2 degrees, I know I want to cancel my radians, so that's how I'm going to do that. I know that's going to go away. And my 180 degrees is going to go on top. Well, this cancels and reduces. Also 60, 7 times 6, 420. The other guys can be done the same way, and of course you can type that in the calculator. It's just faster for me not to do that. The next chunk also is converting, and it's kind of obvious which way you have to convert. You just go the other way. Okay, so stating if something is coterminal. For degrees, we're going to either add or subtract 360 degrees, and then we will see if it's coterminal. So I'm going to pick one. I'm going to start at the 5. So I'm going to clear. I'm going to start at 5, and since it ends up negative, I'm going to subtract 360 degrees. And if I get this, like I do, then yes, they are coterminal. They are exactly 360 degrees apart, and both will kind of look like there's 5 degrees, and the other one goes like that. No, it doesn't. It goes backwards. I wasn't looking. I feel compelled to erase and waste all this time, and I'm sorry. But I feel better now. Okay. For this, we're going to add and subtract 2 pi. Do it right in the calculator, and it's totally fine. So remember my 2 pi, actually, yeah, I am going to do it in the calculator eventually. So remember we said halfway would have been the 12, the denominator, if you're kind of like counting around. So one whole circle is going to 4 pi over 2. See how that's also going to be 2 pi? Over 12. And that also is going to be 2 pi. So I'm going to start with my 17, only the numerator. And I'm going to, since I'm going to the negative, I'm going to minus 24. And if I get negative 7, because we're dealing with 12ths all the way around, then they are coterminal. And in this case, yes, they are. Find a positive and a negative. Well, for this one here, you can add 2 pi, or you're going to take it and you're going to subtract 2 pi. So when I add 2 pi, remember you're going to take that denominator and double it, so it's actually going to be like you're adding 6, so 8 pi over 3, and since we're adding, plus and minus, I'm going to make it 6 pi over 3. We'll do it that way. If I'm subtracting, then 2 minus 6 is going to be negative 4 pi over 3. And here's 30. If you were going to be adding and subtracting 360 degrees to get one positive and one negative, and here I'm only going once around, but if this number is like 530 degrees, then you would have to subtract 360 a few times in order, or, you know, at least twice, maybe 2 or 3 times, in order to get into the negative range. So let's see, if I'm adding, it's going to be 390, and if I'm subtracting, then it's going to be, I don't know, negative 330. It's going to be that way. Okay. Coterminal between here and here. Well, I'm going to take my degrees. What did that say? 9, 30. And since I want to be between 0 and 360, then I'm just going to minus 360. Nope, not there yet. Minus 360. Yep, 210. So that's what I'm going to do. Keep traveling 360 till I get there, just like this one. In this case, because it's a negative, and I'm going to be adding, and it's pi over 6, so I'm going to be adding times 2, 12 pi over 6s. I'm not even going to bother with my denominator, only my numerator. So let's see, I'm going to be taking my negative 17, and I'm going to add 12. Okay, negative 5, but I'm not in between 0 and 2 pi. It's still negative, so I'm going to add another 12. And it's going to be 7, right? So 7 pi over 6 is going to be that answer. All the rest of the answers are given. I didn't need to do too many from each section. You guys are going to do fine.